Hi, so this is a quick review for 2.1, 2.3. Right now I'm just talking about a conditional statement and learn how to do a law of detachment and law of syllogism, okay? And learn how to do conditional, inverse, converse, and contrapositive. So on the first quick review, it's a name two part of conditional statement. The first one you know is hypotenuse. And the other one is conclusion. Remember, this one is the p-value and this is the q-value. Okay. What they want you to do is look at the statement for question number 2 and generate a inverse, converse, and contrapositive. Now, to do that, first you want to make sure it's in conditional statement, if and then. So here you have word if. So we want to put that one first. If this is 6 p.m., then this is not a time for bed. Okay? Now, the other vocabulary you have to do is inverse, converse, and contrapositive. Remember, inverse, you make a negation to both of them. So let's go ahead and put that little note there a little bit. We'll do negation to both. So, take the situational conditions, write out. If it is not 6 p.m., then this is, since we're doing negation of this, so we get rid of its opposite, it is a time for bed. Now, if that's for a converse, that one here you have to switch it. So we take our original statement, our conditional statement, and just switch it. So write if it is not a time for bed, then this is 6 p.m. So there we take our statement and just switch around. We take our hypotenuse and conclusion and we switch it around. And finally, contrapositive. This one here you have to do negation and then you have to switch it. So what I like to do is just look at the converse since it's already been switched and then just go ahead and do a negation. Okay. So here I'm going to write if it is a time for bed, then it is, we want to do negation of that, so it is not 6 p.m. Hopefully simple, just gotta make sure you know the three vocabulary correctly. Okay? Alright, next one, I want to make sure you know how to use a symbolic notation correctly. Let's take a look. P-value here, it's going to be the value of x at 4. And Q right here, it's going to be 3x plus 2. And we just got to read them carefully. This one right here is what? Our negation. The one negation of Q. So here, if you listen carefully, it's 3x plus 2 is equal to 14. We want to make it is not equal. So we're going to make that and just slash it. So we'll go 3x plus 2. Here's my equal sign. I'm going to put a line through it and say it's not equal to 14. So that's my negation. The next one here is say P implies Q. Look at the p-value. So we write if and then form. If the value of x is 4, then So we know it's 3x plus 2 equals 14. So here's my Q statement right here. Okay. Next one, take a look at this. They want you to do negation Q, and after that implies true negation P. So they want to write if and then form. So let's see. Negation Q, we already done it before. Instead of equal, we say not equal. So to make sure we put if and then form. So if negation Q, which is 3x plus 2, not equal to 14, then what will you write? Then write negation of P, so say then the value of x is, negation of B is not 4. So let's write that. Okay. So yeah. Next one, they want you to be able to identify what this do. Okay? They want to make sure you know your vocabulary. So right away, we recognize this one. P implies Q. That is actually your conditional statement. Okay. So that was it. And then, let's see what else we know. This one here, we switch it, so we know that's a converse. Here, we didn't switch it, but we did negation of both, so that one's the inverse. And the last one should be contrary positive. Alright, let's go to the back and see how to do. Remember, you want to try them before I answer them. Let's take a look at this. Number 5 would say, why is the following statement false? And we want to give a counter example. We want to prove it wrong. They say that all prime numbers are odd. If you remember from algebra, your prime number is actually this. 2, 3, 5, 7, all the numbers you cannot break it down except by 1. Do you know something about those numbers? Yeah. But here, the 2 is actually an even number. So now I can just prove it that, hey, that's not true. We get 2 is a prime number, and it's an even. So, my counter example right here, we'll say something like this. 2 is a prime number. But it is not even, or not odd, sorry. There. Yeah? So now we just prove that, hey, that statement is false. 2 is the prime number, but it's an even number. Okay? Last one we want to talk about is determine what kind of law there are. Okay? Let's just make sure. A law of detachment means that you have an if and then, and if the first one is true, so that means the second part is true. If the hypotenuse is true, that means closure is true. So we've got to make sure the first one is true first. The law of syllogism is just a chain of connection. A give you B, B give you C, therefore A give you C. So connect it. Okay? And if none of them work, then you just go ahead and write neither. Let's take a look at this. Focus on the first two sentences first. First one say, if an angle is acute, then it's not obtuse. And remember, this is the hypotenuse right here. Now let's say that angle ABC is acute. Since it's acute, then we know it's a not obtuse. So this one is the first part. So since they say the first part is true, yeah, that means the second part has to be true. So this one is the law of detachment. Okay. Over here, we're taking a different one. You have angle 2 is a Q, and angle 3 is up 2. Yeah. And if angle 3 is up 2, then angle 4 is Q. And here's the last statement. Say if angle 4 is Q, then angle 2 is Q. So we want to look at this statement based on these two information. Notice that these two connected. Angle 2 will give you angle 3, angle 3 give you angle 4. See that? But the problem is, they say that angle 4 is a Q, therefore angle 2 is a Q. They try to go backward. So that's not a law of syllogism. Even though it's connected, they need connected properly. So this one's going to be neither. Let's take a look at a couple more. Now, if you look at this, you have if you save a penny, then you earn a penny. They say that Jennifer had earned a penny. Well, if you think about it, it's just talking about the second part. Just because Jenny had earned a penny doesn't mean she saved it. If you save a penny, then yes, you earn a penny. But here, the second part says that she earned a penny, so it doesn't mean that she saved a penny. So this one is going to be neither. So make sure you don't get this confused with the law of detachment. Okay. Now, if we take a little last statement, okay, this is angle 2 is equal to 40, then angle 3 is 140. If angle 3 is 140, then angle 4 is 40. And then from there they say if this statement is true or not, and how we know. Well, if you look at these two statements, and notice that these two are connected. Angle 2 will give you angle 3, angle 3 give you angle 4. See how this is connected? Therefore, that angle 2 equals 40 degrees will mean that angle 4 is equal to 40 degrees. So this connects together, and they did it properly. So we go ahead and call this law of syllogism. Okay?